is that disease become the predisposition factor of the Actinobacillus pleuropneumonia because of the, I don't know, maybe because of the epithelium of the trachea become damaged, or how it goes. And then how about the vaccine management that the best for the two of this disease?
Okay, we're talking about poultry, but we're talking about pigs, but that's fine. So I think, yes, there is quite good evidence out there that Mycoplasma pneumoniae increases the severity of disease from a number of pathogens. One of them is not one we have any experience of in Australia, and I don't know whether Indonesia does either, which is the PRRS virus, porcine reproductive respiratory syndrome virus. But there's very good evidence that you get much more severe disease when PRRS virus infects pigs that are also infected with Mycoplasma pneumoniae. And one of the things we saw with Actinobacillus pleuropneumoniae in Australia is that we had an elite pig breeding company that was specific pathogen free, so they actually had no mycoplasma in their pigs. They sold those pigs right throughout Australia. They were actually the best breeding company, best source of pig genetic material in Australia. But those pigs did have a quite low virulence strain of Actinobacillus pleuropneumoniae, actually what's called serotype 15. But so it's a very mild form of APP. And what was found was that when those pigs went out into commercial herds, although there had been no disease in the source herd because they didn't have Mycoplasma pneumoniae, once they got into conventional pig herds that had Mycoplasma pneumoniae, they started seeing quite severe pleuropneumonia as a result of that strain that had been distributed with the pigs. So it was really the addition of Mycoplasma pneumoniae that made the A pleuropneumoniae much more severe. So I think very, very clear evidence that when they get together you get much more severe disease. It's probably the effect on cilia, but also the mycoplasmas are often quite a bit immunosuppressive, and so they may dampen down some of the immune responses as well, or at least change the immune responses, and so it's probably a consequence of both of those things, I think. Yeah. And vaccines. So there are vaccines available for Mycoplasma pneumoniae at the moment. All of the ones that are commercially available are inactivated vaccines. They are all about as effective as each other from the data that I've seen. None of them really prevent lesions. They reduce the production loss that you see in pigs that are vaccinated, so they do have some commercial benefit, but they don't really work well enough to completely eliminate the need for antibiotics to completely control problems with enzootic pneumonia. We do have an attenuated vaccine that's now, it's available in Mexico already, still being trialled in Australia, so hopefully that will get out there eventually and it'll be an attenuated live vaccine that'll be available in the future. There is one in China, but I don't know how effective it is. I haven't seen the data on the original Chinese vaccine actually had to be injected intraperitoneally, which is a little bit tricky for a lot of farms. So.
For the rotation of laboratory diagnostic, for the rotation for the students, they usually have to do and solve their case by themselves. So they have to do the necropsy and then the collecting the samples, and then have to check the samples. They have to make the histopathology samples and then do the parasite examination. So if they do by themselves, what is the trick or how to preserve the sample to get more information, and how long it can be preserved? Because they usually do by themselves, so they cannot put it on the laboratory, and they have to do by themselves. So do you have a trick?
They do it by themselves. Do they have formalin or fixative?
Yes, they have it.
Or when you have the tissues in formalin, they can stay there forever. So formalin obviously preserves the tissues as long as they're sort of thin. If they're too big, the center of the tissue is not get fixed properly, and then undergoes autolysis. But if it's a small sample, it stays there forever. One thing with formalin is sometimes it shrinks the tissues. So if you want to measure something, some of the techniques that Glenn mentioned about measuring the tracheal thicknesses, if you store the samples for a very long period of time in the formalin, it actually shrinks the tissues. So measuring the tracheal thickness, for example, today and leaving some other samples for next year, it would not be reliable to compare the results. So you need to do them all at the same time. So if the thickening of the measurement of the thickness is not an issue, you can actually store the samples forever in formalin.
For the microbiology examination, isolation, how long they can keep it on the fridge?
It all depends what sort of bacteria you're dealing with. Some of the bacterial organisms are pretty resistant, and you can actually store them for a very long period of time. Mycobacterium, for example, is an example. It remains viable for years in soil, in environments, in clinical specimens, while some of them are pretty prone to basically been destroyed. So, for example, mycoplasmas, they don't like dryness. So if you take a dry swab, leave them for an hour, they often die, and they don't like acidity. So it all depends what type of bacteria you're dealing with. If you want to use them for PCR, again, if you've got dry swab, quite often the DNA is very stable if it's dry. RNA is a different story. So if you're doing RT-PCR for, let's say, viruses like coronaviruses or other RNA viruses, it actually get deteriorated after time. So you need to actually preserve them a bit better than DNA.